Alright, hello, for this much course I'm going to go over, this is practice set B. I'm going to go over in depth on how to do these problems, so here we go. Problem number 1, first thing I do is I'm trying to solve for this x value right here, so I'm going to subtract over 1/4 and have 11/4. And now when I'm at this point right here, I know this is base e because that's what the natural log says, so I'm going to switch it to exponential form, and you're going to see that countless times on this worksheet. This means e to the power equals x minus 6. And now I can subtract or add this over here, add both sides, and I have e to the 11/4 plus 6, and then it's just a calculator problem. You type in this number here, an e value with this exponent, plus 6, and it comes to there. Alright, on number 2, I have this property of logarithms that says if I have the same base and I'm adding them, I can just multiply those two things together. And so I have 6x plus 3. And then I'm going to do the same exact property here that says, look, e to this power is this, so 2 to the 0 power is this. 2 to the 0 is 1. Solve this equation now, and I get negative 1/3. But this change here from logs to exponent is what we do over and over and over. Number 3, it says f of 5. Well, it used to be f of x, now it's f of 5. So the 5 goes in where the x is. So that's just 2 to the 9th minus 3. Now on the bottom one it says f of x is 5. This one says the input is 5. This one says the output is 5. So I put the 5 right there. And now I have to add this. And then now we're going to do kind of the reverse of what we've done up there. If I have a exponent problem, I can take the natural log of both sides, which makes this 8, which allows this power to come down. Then I can divide this over, and then I can have it equal to x plus 4. This intermediate step right here is the natural log of 8 divided by the natural log of 2 is equal to x plus 4, and then I subtracted the 4 over. So this gets divided over, and the 4 gets subtracted away. And make sure you know this, this is separate. This is a natural log of 8. Let me show you on this calculator here. This is the natural log of 8 divided by the natural log of 2. You have to press that log button twice right there. And that makes it 3 minus 4 is negative 1. Alright, on the next problem, just the same thing. I subtract over the 1 and get 17. And now I have 17, but how do I undo this? Well, I multiply by 3 halves, which makes it 51 halves. So from this line to this line, I subtracted 1, and I multiplied by 3 halves. And now I'm to the point where I'm going to do the exact same step. I have an exponential problem, but if I take the logs, it allows us to drop down. A log of this side is 51 halves, and a log over here, I kind of flip-flop the sides here. The natural log here allows this to drop down here. Divide this one over, subtract that one over, and I have this number minus 1 is here. But again, it's that same idea of this is about exponents, this is now about logs. The same idea here, this is about logs, this is about exponents. And if you get that in your mind, that when you get stuck, you go back and forth between exponents and logs, you'll do fine. The size of a cloud is decreasing at a rate of 15% per minute. Well, that's this rate right here, 1 minus 0.15. The starting volume is 137,000, and I'm trying to get down to 20%. Well, let's see what that is. That's 137 times 0.20, so there's my output. What input is going to get the cloud down to that output? The cloud starts here, multiplied by with some stuff, it gets down there. I can simplify that, can divide that over, and notice one thing, this 20% shows up right here. That's always going to be true. Now I can take the natural log of both sides, which again allows this to come down. The same deal over and over and over again. This exponent became a logarithm. This exponent becomes a logarithm. And now I have this log, divide that log over. This is multiplication here, divided over, and we have it. All right, simplification means do everything that you can do. Well, if I have these logs being added, I can just multiply them. So this becomes log of 100. Well, log of 100 is base 10, so that's 100. So that's a 2 right there, right? This log of 100 is a 2. This is a 4. 2/4 is a half. On number 7, the weight of an object is continuously growing exponentially. Day 5 is 12. Day 7 is 20. Find the model. Well, here's your formula for rate. Make sure you memorize that. It is ln of y2 divided by y1 all over x2 minus x1. There's the rate. The rate goes there. Plug in a point. And now you have, I'll go ahead and write out this step. You have 12 is equal to p e to the 0.2554 times 5. And how do I solve for p? Well, I divide by that whole thing right there on both sides of the equation. Alright, let me show it to you on a calculator. I'm going to take 12 divided by e to the 0.2554 times 5, and there you go. And that gives you the p-value. So we have an object that's starting at that amount, and it's growing by that amount. And we know what the graph is going to look like, right? The graph's going to be that hockey stick where it goes up and it goes down. It goes down this way and goes up that way because it is growing up. If this is positive, it goes up. If it's negative, it goes down. Number 8. Again, we have a log problem here, which is kind of tough. It looks very tough to start with. But if I just change it from a log to an exponent, right? It's a log now, but it's an exponent now. It makes sense. That's 9 to the 1/2 power, which is just 3, is equal to this thing. So that's 9 to the 1/2 power. And if you do 9 raised to the 0.5 power, well, that's just 3 because that means square root. Now we have this right here. The cube root. The cube root cubed are inverse operations, so they cancel out. Now we have 5 minus 2x is 27. You can solve it. If you expand this, all of these are being multiplied, so all of the multiplication turns to plus, plus, and this is being divided. It's being divided. Now what can you do with the exponent? If I were to look at the y by itself, I would have the log of y to the 5th. That exponent comes down, so it's 5 log y. And what about the z? Well, z is to the 1/3 power because that's what the third root means. Well, that power comes down to the front. So this crazy thing is expanded out into all of these parts. Sometimes the math is done with it like this. Sometimes the math is done with it like that. Simplify, a lot of little rules here. ln of 1. Well, that's just 0. Because what this says is log of e is 1. What exponent do you need right there to turn a e into a 1? Well, that's a 0. A to a, 1. W to the 0 power, 1. This right here, if you remember the rule here, we have e to the log e of 3. Those cancel out and I'm left with 3. We talked about why that was, but if you want to remember the shortcut, they cancel out. I'll show you one example of it. If I were to have base 2 log 2 of 8, well, hey, this is a 3 right there. So 2 to the 3rd is back to 8. Those just go away and I'm left with the 8. And that's a negative 3. 2 to the negative 3 turns into that. Add them up, we have 2. A colony of ants is continuously increasing at a rate. Alright, well, we have 2 points here. 0, 5,000. And after 5 weeks, it's up to 8,000. The question is, what's the formula? Well, There it is. And it's the same thing we did back on this problem. We used that formula right there. All right, nice, got it. There's my rate, goes there, but look what I did. If you remember this problem, we had to do all of this work right here to figure out it started here. But take a look at this. They tell me where it starts. It starts at 5,000, so I don't have to do any work for that. And the last thing I do is put in 10. Let's double check the math. 5,000 e to the 0.094 times 10. There you go. 1279. Very close if you round it. All right, and again, what's our common message here? If we have a log problem, we switch it to an exponent. 3 to that power is that. 3 to the third power, let's go, well, 3 to the 8th power, let's try that. 3 to the 8th power, and I multiplied it by 2. It's 13,000. Add the 9 over, and we're here. All right, same old story, watch. I divide by 6, and then to get this exponent down to the front, I take the natural log. Natural log of 2, this number comes down, natural log over here. This gets divided, and I have that. Any log would work here, but why not just use a natural log all the way through? All right, my graph's a little bit different from yours. I changed it a couple times, but here's what it finally ended up being. We have a graph that has been shifted down 2 units because of this, left 1 unit because of that, stretched vertically by 2 because of that, and flipped across the, not y-axis, sorry, the x-axis because of that. Take a look at this graph. This graph is a graph that curves up. This graph has been flipped, moved, stretched, and shifted down 2. This line is now at y is equal to -2. It's moved down. It's not at the origin. And notice what I did. I scaled my graph to fit my range here. The range is all the outputs. It goes from 0, from a -3 down to a -164. I went ahead and scaled it down to -200. That way I could account for all my points. And there's that hockey stick graph. This side is going down to -infinity. This side over here is going to the asymptote, which in this case is -2. One side goes to an asymptote, one side goes to -infinity. That's exponential growth. And that comes from this equation. It starts there and it gets turned into this. All right, hope this helps with your practice problems for your test. If you have any questions, please see me in class.